Solution of the word problem on exam 1 lies in knowing what it means to represent a 4-bit number x using 2's complement. Okay, so what we know is that the positive numbers are pretty easy. All right, so we could list the positive numbers. I like to group them off in 4s to keep things lined up a little better. Okay, so this is, if you were looking at sign numbers, this would be sign number 0 through 7. Okay, but then what if I was going to look at -1? All right, so if you remember -1, there's a 1 in the, I'm sorry, let's do -8 to keep these in order. Okay, what if I was going to do -8? All right, in 2's complement, it's 2 to the n plus x, where x is -8. Okay, and so that would be with n equal 15, I'm sorry, n equal 4 for 4-bit, it'd be 2 to the n, so it's 16 plus a -8 equals 8. Okay, so 8 in binary is 1, 0, 0, 0. All right, so we've actually done this several times in class. All right, so if you extended this down, what would this represent? There's another way of looking at that. I'll do it that way. 2's complement, you flip all the bits and add 1. So this would be -7. And you can keep going with that pattern all the way down to the end to get -1. Okay? So this would be essentially the minterm list. Let me go ahead and fill it all out. Okay, so let me put the whole table in here. 0, 1, 2, 3, 4, 5, 6, 7, -7, -6, -5, -4, -3, -2, -1. Okay, so this is the signed representation showing up in this truth table. And so you notice on this side, what we have are the minterms, 0 through 15. And we need to know when is the magnitude of x less than or equal to 3. Okay, so that puts the 1s for our Boolean function. And so 0 is less than or equal to 3, so we get a 1 there, a 1 here, a 1 here, and a 1 here. Down here it would be 1, 1, 1, and the rest of these are zeros. So our problem reduces to the Boolean function f is sum of minterms. And so we look at the list, 0, 1, 2, 3, and then we have 13, 14, and 15. So from there, I can make a Carnot map. A, B, C, D. The usual way. So there's my Carnot map. Now I put the 1s on the Carnot map, I'll make those stand out with red. 0, 1, 2, 3, 13, 14, and 15. Okay, so from there, you can do SOP or POS. Let's take a look at SOP. All right, so SOP, I'm trying to cover, for example, this 13, and I can get that with a group of 2 here. Okay, and then I need to cover 14. Here's another group of 2. All right, and then finally, to get 0, 1, 2, and 3, I see a group of 4. All right, so reading off the map, all right, so for the green group, I have that completely inside of A. It's completely inside of B. It spans C and is inside D. All right, so that would be the green grouping. And then for the blue grouping, I have completely inside of A, completely inside of B, and completely inside of C. All right, so there's the blue grouping. And then finally, the purple grouping. I have the purple group is completely outside of A, completely outside of B, and it spans C and D. All right, so there's the purple grouping. All right, so this would be one possibility. All right, this is, of course, sum of products. We could also check product of sums. All right, so with product of sums, I'll change the colors here. With product of sums, what I want to do is circle the zeros, avoid the ones. Okay, so it looks like what I can get here is I need to cover midterm 12, and I have a couple of choices. One is, let me do it with a different color. One is right here, okay, and then the other, that would lead me to a group of 4 for max terms 4, 5, 6, and 7, and a group of 4 for 8, 9, 10, and 11. Or I could choose this, they're equivalent in terms of minimization. All right, so let's do that one, and then that leaves us 2 other groups, this blue group here, and a, we'll call it a gold group here. Oh, that looks too much like yellow. Let's go light green. Okay, so to circle the zeros, I would get F, let me change that back to black. I'm making a circling for F bar. All right, so the first yellow term would be inside of A, it spans B, it's outside of C, and outside of D. And then for the blue group, we are outside of A, we're overlapped with B, and then we span C and D. And then finally for the, well, let me color these. This first one was the gold. This one was the blue circling of the zeros. And then finally we're going to get green with, we're inside of A and we're outside of B. we span C and D. Okay, so that'd be the green grouping. All right, but that's F bar, and so from there we would apply De Morgan's, and I can do that all in one step. This would be A bar or C or D. You complement the variables, and you turn the sums into products. I'm skipping a few steps, but this is how it works out. If you do a few of these practice problems, you'll see that's a pretty easy step. Okay, so both of these are valid expressions. I suppose that technically speaking, SOP is slightly more minimal because it has one fewer, it was 3 terms, 1, 2, 3, 1, 2, 3, but one of these terms has 3 inputs, whereas up here 2 terms have 3 inputs. All right, so this would be the logic expression that's truly minimal, based on our definition of minimal for this class. All right, so there's the walkthrough for solving the word problem. It took me 10 minutes or so to go through that, but I was explaining as I went. So I think, if you saw a problem like this again, you'd know to jump straight to a truth table to represent signed numbers, and then you could implement whatever, inequality type of math expression that you wanted.